So vector u is going from 0, 0 to 3, 2, that position 3, 2, right? Because it started at 0, 0 here, this vector is identified by 3, 2. I think what they want is a drawing by the principle of adding vectors, geometrically defined, not algebraically actually computing. That's what they want. So if it is two force vectors like that, how do we add these two? Using parallelogram law, right? That's what you're supposed to be doing. How about negative 2v, 2u? 2 times the vector, but opposite side, right? That's what you should be doing. All right. Okay, were you able to draw like this? U plus V, the parallelogram, this from here parallel to this one is perfectly horizontal, and this one is kind of parallel to this U, and that's where it meets, and that's the vector. 2U would be this one 2 times in the U direction, negated is opposite direction. So it's supposed to be a perfect line. It's a little bit crooked shape, but it's supposed to be straight line. All right. How about this component? How do you find the component? Rather than reading off this coordinate by carefully sketching it, and how is this vector supposed to work out? This component of u is, what is this component of u? Right, 3, 2, right? Is that right? That's how much of the 3 units here, 2 units above, right? Not necessarily the coordinate of this terminal point. That's not the vector component, right? This displacement amount is what this vector is. And this one here, this vector, that's going to be 2, 0. So how do we get the component? It's supposed to be adding this 2. So it's 5, 2. And if you carefully sketch it, it's supposed to be 5, 2. It doesn't quite look like 5, 2. Because the scale is different. Here's 2 units here. I don't know. It's supposed to be 5, 2, right? That should be correct. I think it's scaled a little bit different. Yes. That's right. That's the displacement. If it is start from somewhere else, for example, here 1, 2, and 5, 3, then what is this vector connecting in here? Right. This is not 5, 3. 5, 3 is not a vector, right? How much it moved here? How much above that? That's a displacement vector. So if it is a v, how much you go to the right? 4 more units, right? To get to 5, so it's a 4. How about the y component? 1 more unit. So vector here is identified as a 4, 1. Not 5, 3 or 1, 2. Right? That's a displacement vector. Records how much is displaced along the x-axis and y-axis. Any question?
There's not going to be any notation difference between the position vector and the displacement vector.
Right, it's just the context you have to. I try to be more specific when I'm writing it, and especially in the test. And this is a position vector, and when you're calculating, sometimes you have to interpret it correctly on your own because there's no other interpretation. This must be the displacement vector, things like that. But yeah. So this one here is like a position vector, right? It's because it's starting from 0, 0. Because it's 0, 0, that n coordinate is the displacement amount, but in general, it's not. Any other question? So, if the vector is displacement vector and force vector, whatever, the way it works, if you understand what the components of these vectors are, always when you add, just adding this component y's and scalar multiple and just multiplying the scalar. I forgot to do the other one. What is the other one here? I'm sorry about this. This is 3, 2, right? So what is the coordinate here? So multiply -2 there to that component. So that's -6. Multiply 2 there is -4. Right? That's the vector. Sorry about this going back and forth. And this is something I already explained yesterday. This is a displacement vector, right? U and adding another displacement. And y is u plus, that's the definition of u plus v as introduced yesterday. Y is adding these displacement components is a correct answer. It's showing that go to the x displacement and further x2 displacement, and that's how much this is displacement works. And the same along the y-axis as well. And if it's a scalar multiple, then it's the same thing. All right, so that's a picture that explains. And this is 2 force vector applying in there, and the sum is this diagonal, and they're interpreting also as displacement vector as well here, right? If you recognize this v and that v is the same vector because there's parallel, and if this is a parallelogram, it looks slightly off, but if this is a perfect parallelogram, and that vector, although it started from different places, their component is the same. So adding this 2 vector is interpreted exactly the same as adding these 2 vector. And here, according to our definition, parallelogram or chasing each other, they end up at the same length and same direction. So they coincide. That's what this picture is explaining. All right? So all you have to do is just add those components. That's basically the bottom line of all these things. Different interpretation, always doing the same thing mathematically. This is an interesting picture, so I'm going to introduce it here. Now we're adding these 2 vectors, right? I'm about to introduce subtracting the 2 vectors. So if I have vector v vector w, right? So I want to subtract w from vector v. Okay? So if that's the u vector, so I'm using this picture v going to that direction and w going to that direction. And even though we're looking for a subtraction of the 2 vector, meaning of the subtraction of these 2 vectors, do you think you can interpret this as a displacement vector? Let me just not write that there. If I put another vector like this, don't you think this vector followed by that vector must be the addition of 2 vectors, right? So if I put that u there, if our interpretation is correct, the w plus u must be what vector? V vector, right? So that vector, if you rearrange this one and see what is the interpretation of this vector in here, u. So let's solve this thing for u. If you believe this is the same arithmetic applies, and what is u? V minus w, right? So v minus w, the meaning of the v minus w, if you have 2 position vector like this, then it is this vector along the remaining, so that it creates a triangle, not parallelogram. So you don't want to repeat this over and over. You just have to memorize it. So how do we add this 2 position vector? Use a parallelogram, right? How do you subtract the w from v? Use a pointing toward to the v along the diagonal. Yes? That'll work too. Right. That's the next thing I'm going to do. Right. So that's the so you can do that without putting any extra lines. That's what I like this about. It's pretty neat. No extra line. The dotted lines are required. So that's one interpretation. And Andrew was saying that here's a different interpretation. What about interpreting this one as a opposite direction of the w, right? So why don't I put negative here? Does it look like negative w? Yeah. If I add v and negative w, it must be pretty much the same interpretation, right? So here's v plus negative w. That must be the definition of v minus w, right? So how are we going to add these two vectors? Not subtracting. Here's adding, right? Then you have to do the parallelogram. Parallel line to that w and a parallel line from here to that v. And then it is that vector must be v minus w, right? Or v plus parenthesis negative w. How about these two vectors? It's supposed to be parallel perfectly, but that's the same interpretation. Here's v minus w, should be interpreted like this, and that's actually parallel. So that's the v minus w as well, right? As a displacement vector, they are the same vectors. Make sense? So I like this version a lot. This is more useful for the problems that come in, rather than keep interpreting this way. Well, just memorize here, right? If I have vector w there and vector v here, what is w minus v? Going to the right or going to the left? W minus v. Going to the right. This is the first component, toward to the first component. And that is w minus v. Alright? Makes a triangle. And that's written here. So if you go w followed by b minus w, of course the w cancels and becomes v, right? It's easy to see that as the correct. So that's pointing that direction, v minus w. So you know how to subtract one vector from another, right? So with the displacement vector, I think there's a natural interpretation of this thing. All right, great. So this is a fun problem. Right, maybe it wasn't necessary to do that. Let me just keep it there. If you have a point P has coordinate x1, y1, right? Is this a vector, this x1, y1? You can interpret it as a vector, right? It could be position vector, right? If I say position vector, if I have a point 5, 6, that doesn't look like a vector. It's just a one point, right? You can turn that into a vector by always drawing line from 0, 0. Okay, so that's a position vector. That's what how they're interpreting. Position vector there. And here's another point Q, and OQ can be interpreted as a position vector, so you can interpret that as a position vector. So what is this displacement vector PQ? Is that if you look at it, this is joining these two vectors from one vector to another vector. So if you are familiar with this vector, starting from O, then end of the Q, that's the notation, the vector, displacement vector, right? Because the starting position is O, you can interpret it as a position vector as well. So there's OP vector there as well. What is the operation do we have to do so that I get this remaining triangle? We just looked at it, right? So did I write this in a wrong order or correct order? OQ minus OP will be this vector minus that vector, right? So you know it should toward to that vector that's in the first term. So that vector PQ must be this one. So what is the position vector there? X2, Y2. OQ minus OP is a position vector x1, y1. You just subtract this vector and get this x2 minus x1, y2 minus y1. Which is not the only way to understand this one, but I use that vector subtraction to explain this one. If I have x1, y1 and x2, y2, what could be the displacement vector? You don't have to use vector subtraction. You can just go to the coordinates and figure that out. But it's also a neat interpretation with the vector addition and subtraction. Oh, that makes sense? Yeah.
Could you re-explain why it's OQ minus OP instead of that?
Right. If you have two vectors and W and V, if you're subtracting V from W, then answer is you go to that direction. The W is the first term, you have to go to that direction. That's a quick answer. Explanation could be if you put W minus V, if you follow by this one and that one, that's a displacement vector addition, right? This V cancels and becomes W. If you put V minus W and think about this one, if you add these two vectors, it's supposed to be W. You can see V and V doesn't cancel. It doesn't give you W. So it should be W minus V if 2 of the thing is the right one. So that if you add these two vectors, which is a displacement vector, then V cancel, it becomes a W. It's consistent. All right? So you have to go to the first term of that subtraction expression. Fair enough? All right. Let's do these two problems. Is that going to be second exercise today? So rather than just figure out the answer of this one, just to interpret it, okay, that's the position vector 3, 5. Maybe you're going to draw the position vector there, and that's another position vector. From here to there, you draw the picture. What should be the formulation? So if I call that one P there, call it Q there, and try to use the vectors to answer this problem. Component of the vector from P to Q. So let me help you with this first bit. What I mean by this one, here's a P. It's an arbitrary picture. Not necessarily it's accurate, and sometimes that's just enough. Here's a P. We can interpret as a 3, 5 as a position vector from 0, 2, 5. And here's an arbitrary picture. Another one, Q. There's that vector, OQ. So they're saying, what is this vector, a component of the vector, from P to Q? So what is P to Q? Is that vector right there, right? They want you to compute that vector. So with this diagram, how are you going to go about that? What vector minus what vector? Write that component of each vector and subtract it using ordered pair. Let's check our answers for part A together first. Answers 1, 2. Like I said before, you don't need these vectors to understand what the displacement vector is. To go from here to there, you got to increase your x-coordinate by 1, right? Increase y-coordinate by 2. Therefore, the displacement vector is 1, 2. I just put it into this context more in terms of position vector, because you're going to do a lot of computation with position vectors. So I want you to interpret it and the operation done on position vectors. Right, does it make sense? OP, OQ, position vectors, if there's a coordinates. Any question in part A? Let's think about part B. Add the vectors, the vector v from -1 to 0 to -3 to the second vector w, that's 2, 0, and 1, 1. Right? So just to compute the component vector v, you don't have to do it position here. Think about a component vector w, component of w, and think about how to add those two vectors. So here's some pictures. I'm going to call that one point A and point B. This is point P and point Q. They're talking about vector starting from A to B in the plane That's the v they're talking about. And this point P is different place, right? Negative 1 comma 0 is where it starts, 2 comma 0 somewhere else. So I just chose a random point here side. And here's another vector going to Q. That's a W, right? They're asking you to add these two vectors, right? Don't think about how we're going to interpret it. Just simply add these two vectors. We thought about it. Force field, the parallel transport. If it is located in different places, how are you going to add these two vectors? What's the secret? Just add the components of the vectors. Simple as that. All right, how is it? Is that good? So you're not going to add two coordinates and down there two coordinates and like that. You first have to compute the component of this vector. So make sure you get this vector v turn out to be 3 comma negative 3. Is there any question to get this component correct? The vector v is 3 comma negative 3. That's not the coordinates, right? That's the displacement amount. Any question about v being 3 negative 3? The same for w. That's the displacement amount is negative 1 and 1. Right? They're living in different places, but we just add them as if it is force applies to the same position. So if you add the components, and then you get 2 negative 2. If there are mistakes, probably you might have just add this coordinates to here and there, and that's not the correct way to do it. Is there a question, sir?
Yes. In the case of W, why do you subtract 2 comma 0 1 comma 1 instead of the other way around?
The point P is a 2 comma 0 here, right?
Yes.
And Q is 1 comma 1.
Yes.
So that's 1 comma 1 here. So if you're going to that direction, so here is W, and here's, let me use something different. W1 and W2, right? So we're looking at this vector right here. That vector is a W1 minus W2. So that point here, where it's pointing, is a first term. And subtract second term. I didn't really explain why, and that's the rule that I explained. I'm repeating a third time. Yes. Yeah. How about this one and B? Isn't that consistent here? Yeah. From A to B, from P to Q, right? Any other question? Yes.
If you draw out those two displacements, if you set an coordinate of 0 and you do the W, negative 1, 1,
Mm-hmm.
negative,
That's right. Yeah.
isn't it just like a straight line?
Let's see. If you want to interpret it correctly here, this is the x-axis, y-axis here, and x-axis. So displacement, sketch it together. V will be 3, negative 3 there, right?
Oh, yeah.
I'm sorry, 3, negative 3 here. Correct? So that's going to be V. And the W will be 2, negative 2. So it's a 2, negative 2. Oh yeah, this is the answer. It's negative 1, 1. So it's negative 1, positive 1, and here, right?
How do you draw that parallelogram if it's just a straight line?
Oh, that's good. Yeah, it's pointing the same direction. So the parallelogram is just going to be the line. So you can't really draw the parallelogram. But it's because it's a kind of in the same line, all that matters is magnitude. That's correct. So here is the resulting force is, this is 1, 1, 1, so it's just 2 units down there. That's the resulting force. That's a good question. I didn't think about the situation. The parallelogram is awkward to interpret that way, but in the force-wise is easy. If you're pulling with the 3 Newton here and pulling to that direction into 2 Newton, if the force is applied, the resultant force is that 1 Newton to the right direction, right? So you can interpret that and translate that information to coordinate-wise. Right? So that will be singular case for the parallelogram interpretation, which we had to cover, which I forgot. Very good. Good comments. Right. Any other comments, questions? What was the third question? Multiply vector, we computed by 8 and represented by, let's think about this one. We calculate this vector v to be what components? 3 comma negative 3, right? In part B. So that's displacement or force applied somewhere. And we're going to multiply by 8. And if this vector, so let's say that vector 8 times v, so what is that vector? 24, negative 24? Is represented by directed line segment from 5 comma 6 to something. So here's 5 comma 6. And here is 8 times v, right? And what is q? And here's a q, and here's a p. They gave you p, 5 comma 6, and there's a q unknown, but this directed vector from p to q supposed to be the same vector as 8 times v. 8 times we have just calculated here, right? Hope that question makes sense. We have a displacement vector given by 8 times v. Your initial point is a 5 comma 6. What is your terminal point? Right?
Is this for the exercise?
Yeah, I'm about to make an exercise. It seems like it's reasonable from here. I have to explain this much. Is that all right? So we're going to write this unknown thing, what? X comma y, right? And displacement vector is 8v. And what is this x and y, right? That's your exercise number 3. Is that right? 4? Right, that was a separate, well, yeah, let me continue then. It's all right. Doesn't matter to me. Let's continue. Any question toward understanding what it's asking, or something that it doesn't make sense to you? Yes?
So we're finding the component of Q that's manipulated by 8V.
Right, pretty much. Component of this position Q manipulated by 8v. Right. Yeah. Right, was that okay? Right. I realize it is better just to add the vector on the other side rather than dealing with a separate equation.